Right, let me give you one question on this based on our discussion we have just had on how to find the velocity or speed of a satellite. Then after this example, I will give you one to try as exercise, okay? A relay satellite was placed in a parking orbit. The key term here is parking orbit. So you should first ask yourself that when you say parking orbit, what is it? Let's continue. On the Earth's surface, calculate the velocity of the satellite. On the velocity of the satellite, radius of the Earth is 6.4 times 10 exponent 6 meters. Acceleration due to gravity, sorry, 9.81 meters per second squared, and our universal gravitational constant is 6.7 times 10 exponent negative 11. Okay, Newton meter squared per kilogram squared. That I was asking that when we see parking of it, what does it mean? We discussed it in the course of this. We have discussed this in our previous lessons, and we said that the parking of it, the satellite is said to be in parking of it. And if the period of that satellite, or we said that it rotates with the same speed. When the satellite rotates with the same speed and direction as that of the Earth, then we say it is in a parking orbit. So what does it tell you here? If the question is saying the satellite is in a place in a parking orbit, what is he implying here? So let me create my board. How do we go about this question? This is a very important fact I want you to note on parking orbit. When we see a satellite is in place in parking orbit. So since the satellite is placed in parking orbit, then okay, then the period of revolution of the satellite should be equal to the period of revolution of the what? Of the Earth. Because we said that a satellite is placed in the parking orbit. Let's just say satellite and one it rotates with the same speed and direction as what? The Earth. Let's say the satellite will have the same period as the Earth. So what is the period of revolution of the Earth? It's 24 hours. So here they have indirectly given us the T, but you may not know. So this implies that T of the satellite, okay, is 24 hours. Okay. So question now, so my radius of the Earth no. So can come as okay, our question me list radius na small gene big gene na mama yen list so that we can use them in our calculations. Okay, good. Radius of the Earth, and we know that this symbol is big R. This is 0.4 times 10 exponent 6. Okay. My board has frozen. Let me just wait for a while as it recovers. Okay. Oh, yes. Thank you. I'm back. So meters. Then our small g we know to be 9.81, and our capital G as 6.7 times 10 exponent negative 11. Okay. So velocity v of the satellite is what the question is demanding. Okay. So how do we go about it? We made one mistake. We should have converted the period to, how do you call it, to our seconds. It's supposed to be in seconds. So t, I mean our t. The t is 24. We know that 1 hour is 3,600 seconds. So 24 hours. A minute, dear people. Okay. T is 24 hours. 1 hour is equal to 3,600 seconds. So 24 hours will be what? Be 24 times what? 3,600. And this is going to give us 86,400 seconds. So this is going to be our T, our period. Okay. You realize that all the formulas for the period involves our aim is to, the question wants us to find what? What does the question want us to do? The speed. All the formulas involving the speed contain R. So we need to get small r. So our focus is to find the distance between the satellite and the Earth from their centers. So our focus is to find small r. Okay. If we get small r, then we can easily get our speed. Because the question wants us to find the speed. Okay, so we continue. We are still continuing with what we are doing. So we know, okay, we know that t squared is equal to what? 4 over it's supposed to be gm, right? But let's look at the information we have from this question. Is it possible we can use that formula? We weren't given the m, we were given the r and the, so we can see, because we have learned in our previous lesson that gr squared equals gm. So instead of putting that formula, I can see that instead of gm, I can put the small g capital R squared there. For those ones, I know them in the question. Okay, let's try and make small r the subject. What do we get here? Cross multiply, we get what? T squared g r squared equals 4 pi squared r cube. Okay, so what do you get when you find r cube? When r cube stands alone, that is, you divide both sides by what? 4 pi squared. So t squared gr squared over what? 4 pi squared. Okay, and what do you do? Here there are two ways. You can find your r squared straight, and the final answer you cube root it. This is r cube. So let's fix in. We got our t to be 86,000. Okay, times 9.81 times our r, our big R, all squared, all over what? 4 pi squared. 4 pi squared. So that is what we are saying. And what do we get for this? When we find this, we are going to get calculator is going to give us. We enter this everything on the calculator. Times 10 exponent 22. Okay. Then what do you get for r? You take the cubic root. You get r to be what? 4235 4426.97 meters. That will be our r. Okay. So now, luckily for us, we have gotten our r. Finding our speed will be easy for us since we know our r. So let's continue on this new page. Speed V is 2 pi r over t. And this is what? 2 pi, the r is what we have got in there. 423.544 26.97 all over what is 86400. Okay, and what do we get by division? 3080.10 speed. So here the units. So good. So that is how we go about this question. We started it this way. This was a question frame. We were told that the satellite was placed in a parking orbit. So we use the fact that if it's placed in a parking orbit, then the period of revolution of the satellite will be the same as the period of revolution of the Earth, which is 24 hours. You convert this 24 hours to seconds. That's what we did here. Okay. So we convert it to seconds. Then you realize that all the speed expressions contain small r. So with this period, you can find the small r, which is the distance from the center of the Earth to the satellite. And on your finding, use the satellite period formula now. You define r. R now. After getting the r, then we can easily find the v. Is that clear? Good. Let me give you one to try. Let me give you one to try. Your hands on.